Okay, in the last little bit we were talking on DC generators, and we left off on that. We were talking about this being a split ring and how these DC generators work as this coil or loop, or another term is armature. As it flips around in a circle, it experiences magnetic flux, which we kind of talked about and showed in class. And so when that happens, it's cutting across these perpendicular field lines that always go from north to south. When it does, it generates electricity, and it gets the most whenever it's at this point right here. When it's vertical, when that loop or armature is sitting vertical like this, and it's moving like this, which is parallel to the field lines, at that point you get zero magnetic flux, and you get zero current or electricity out of it, because it's moving the same direction or parallel to those lines. It's got to be perpendicular to get the maximum amount. Now that's if you take and you are turning this, you get the electricity. But the opposite also happens. Say you have this hooked up to a battery. If you have this hooked up to a battery, these are brushes right here, which they're also brushes on a generator, but the battery produces a little magnetic field here, which in turn produces a little magnetic field, electromagnetic field within this wire, which is experiencing the same flux with this, with these magnets. When that happens, the generator begins to turn, and this armature or loop begins to turn around a circle. And so it's the same thing, it's just happening backwards. You're adding electricity and you get it to move because of the electricity. The other way, as a generator, you move it and it makes electricity. So DC generators and motors are basically the same process, they're just reversed. Okay? And again, that's DC. And by the way, that split ring is also known as a commutator. Okay? Now an AC generator is a little bit different. Okay, here's the AC generator. It's still the same setup where you have two magnets. You have the magnetic field always pointing from north to south. You have this armature or loop. Okay, but down here you have two rings. Okay? With the two rings, because they're attached to opposite sides of this wire, so you have one red, one blue, and it's just kind of dividing. What's going to happen is as it turns over, you'll have the red side over here and the blue side over there. It flips, right? Well, and this ring right here is up against a brush right there, and this ring is up against this brush right here. Okay? And they pick up on the magnetic changes inside this wire, which are actually just electrons moving. Okay? You get an electromagnetic force again, and that's, or electromotive force, known as EMF, electromotive force, which is voltage. Okay? That voltage is produced by this change of electromotive force. Alright? As it's turning, you have this side over here, that side over there, and you get a continuous change in the direction of the electricity because of that. It just flips back and forth. As it's moving, with these two wires being constantly connected, not broken apart like the split ring, you have a current that's developed that's AC. You have an alternating current because it's changing direction. That's the key with an alternating current, is a change of direction. Okay? And that's the end.